All right, I think we're recording. This video is going to take us through solving quadratics by factoring. And it answers the question, what do we do with the factors once we have them? We have spent the last several class periods just looking at factoring. We've looked at factoring a GCF. We've looked at factoring the difference of squares. We've done factoring with the area model with the tiles, and then we moved the tiles to a generic model, and then we practice. We spent a whole class period just practicing. And so that's a lot of time spent on factoring. Why? Okay, what do we do with these factors once we have them? And that's what we're going to get in here today. So what have we covered already? This is just kind of getting us up to speed. What are the things that we've already looked at? What's the important stuff? Well, we've learned that a quadratic is characterized by the x squared. So when we're looking at factoring quadratics, that's our tip-off. And if you've been doing all the problems in the assignments and engaging in class the way you should be, you've seen so many quadratics at this point. Like we're probably getting up close to like 40, 50 different kinds of quadratics. You recognize what they look like. Solving a quadratic means finding the value or values of x that make the equation true. Super important to know. That's the definition of a solution. So when the directions say solve, that's the thing you're being asked to do. Okay, you're being asked to produce the value of x that will make it true. We can solve some quadratics by taking a square root. We can solve all quadratics using the quadratic formula. Okay, so you might think, well, if I already have a way to solve all of them, why are we covering something else? Some quadratics are factorable, and that means they can be written as the product of two factors. And then like underneath my face there is the word factors. You just have to take my word for it. Okay, the product of two factors, and that means two things that are multiplied. So you might have A times B. So you can take the quadratic and you can break it up into these two things that are multiplied. Now, at the tail end of the last assignment, you were to explore the zero product property. That was an exploration, just like I'm going to play around with this. And hopefully we've reviewed it in class or you looked it up online. But if two or more factors are multiplied and the product is zero, okay, hence the name of the property we've got there. So we've got let me try that. Product is zero. There we go. So that's why it's called the zero product property. Get that? It should make sense. Then at least one of the factors must be equal to zero. Oops, I didn't turn off the highlighter there. Okay, so here's what that means. If you've got x times y and x times y is equal to zero, then either the x is equal to zero, okay, or the y could be equal to zero, but there's no way that neither of them can be zero. So you cannot have this kind of situation here where you have something that is not zero multiplied by something that is not zero and somehow get a zero out. Like that will never happen. And that's what that exploration was driving at. Not that zero times anything is zero, but kind of working the other way where if you have zero, it means one of the numbers has to be zero. There's no other way to get a zero, okay? So that never happens. That's like bad, okay? So bad, that cannot happen. Now, here's where it ties into the quadratics. If you have two factors, okay, two things multiplied by multiplying together. So one of those things could be x plus 2. And the other thing could be x minus 3. And when you multiply them, the product is equal to 0. Then what you know is that x plus 2 has to equal 0, or x minus 3 has to equal 0. Like one of those has to be true. And it could be either one. Either one would work. Okay. So, and then you could, from there, you can figure out what x could be. So if x plus 2 is 0, then x would have to be, and you can kind of do this out, all right, x would have to be negative 2. So if I come over here and I plug in negative 2, okay, oops, into that equation, Okay, negative 2 plus 2 is 0. And now I don't even care what this is. I mean, it's a negative 5, but I don't even care what that is because 0 times the negative 5 will give me a 0, and that will give me a true solution or a true statement. So x equals negative 2 is a solution, but it could be that the other factor might be equal to 0. Okay, and so you might have this, you might add the 3, and you say, okay, x is equal to 3. So if I come over here and I plug in 3, well, now I have 5 times, and now the 0 is in the other position, but it's still a true statement. 5 times 0 is just as much 0 as 0 times negative 5 is. And so both of those numbers are solutions. And that's like the key piece there is when you factor them, then you're able to use this zero product property. So how does this give us a way to solve quadratics? I think I kind of went through it, but suppose we want to solve x squared minus 2x minus 24. What are our options? Well, we've got the quadratic formula. I cannot use square rooting on that because I have that x term in the middle, but I can use the quadratic formula. So we're going to just do a review of the quadratic formula. We have a is equal to 1, b is equal to negative 2, and c is equal to negative 24. The quadratic formula is this. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of negative 2 is 2. And then we're going to have b squared, so that's negative 2 squared, minus 4 times 1 times negative 24, all over 2 times 1. And so this will be 2 plus or minus. Now, right in here, negative 2 squared is 4. And then you might need to bust out a calculator. 4 times 24 is, what is that? 2 times 24 would be 48. And 48 times 2 is like 96, I think. So 96 over 2. 4 plus 96 is 100. And we can keep going. The square root of 100 is 10. And so I'm going to have two answers. I'm going to have 2 plus 10 over 2, which is 12 over 2 or 6. Or I can do 2 minus 10 over 2, which would be negative 8 over 2 or negative 4. And so my answers there are 6 and negative 4. And both of those work. And sorry, I'm over the negative 4. That better? Over to the side there. So you got your two answers there. The whatever we're doing, 6 and negative 4. Now, before I go to the next slide, because once I go to the next slide, I can't go back. In class, I can click back and forth, but cannot do it in a recording. So take a look at like just the body of that work. Okay, not a lot of thinking involved. It's very mechanical, but it is kind of a lot. All right. Now, suppose I want to solve this by factoring. So how does factoring compare? Well, the first thing you need to do is you need to make sure the quadratic equals 0. That's the same as for the quadratic formula. Both of these, you have to have a 0 on one side. With factoring, absolutely, because that 0 product property doesn't work with any number other than a 0. So you make sure the quadratic equals 0. This example, it equals 0. Now we've got to factor it. Now I'm going to do the factoring off to the side here. So we're going to have our x squared and our negative 24. And then we'll do 1 times negative 24 to get negative 24. And I'm looking for two factors of negative 24 that add up to negative 2. So you can kind of tinker around with that. We have 1 times 24. 2 times 12, 3 times 8, 4 times 6. 4 times 6 will get me the 2. If I subtract them, if I want it to be a negative 2, then the 4 would be positive and the 6 would have to be negative. So we'll have 4x and negative 6x. GCF between x squared and 4x is x. X times x gives me x squared. X times 4 is 4x. X times negative 6 is negative 6x. And negative 6 times positive 4 is negative 24. So my factors are x plus 4 and x minus 6. And now that I know that that is equal to 0. Now, the last part of this is now figure out the values of x that would make each factor equal to 0. If I have two factors, x plus 4 and x minus 6, and the product is 0, then it must be true that either the x plus 4 is 0 or the x minus 6 is 0. And this one I can solve by subtracting the 4. So x is negative 4. This one I can solve by adding the 6. And there we have it. Now, this is the same problem that we did with the quadratic formula on the previous slide. If you want to rewind the video, take a look at that and just look at the body of the work. How much work does it take? Is it filling the screen? What is that work like? Okay, so factoring does give us another option for solving the quadratic. Now, why do we prefer factoring? Generally, factoring is much cleaner than using the quadratic formula. Yes, you might have that area model. The area model would just kind of float off to the side. That would be your scratch work for the factors. But generally speaking, you don't have to tangle with the square root. You don't have to tangle with all the positive and negative numbers. All of that is taken into consideration in the factoring. So let's look at a second example. So this one does not have the 0 on one side. You do want to make sure that you get the 0 on one side for that. And I'm going to get the 0 on one side by adding 5 to both sides. So we'll have 2x squared plus 7x plus 5 is equal to 0. And now I'll do my area model off to the side here. So we have 2x squared and we have 5. And we'll do 2 times 5 to get 10. And I'm looking for two factors of 10 that add up to 7. So we have 1 times 10 and 2 times 5 to play around with, and 2 and the 5 is the pair that gets me to the 7. So we'll have 2x and 5x. Now on this one, I'm going to do the GCF in this direction because I know the 2 and 5 don't have a common factor. So the greatest common factor between 2x squared and 5x is the x, and that'll go up there. Then x times 2x would give me 2x squared. 2x times 1 gives me 2x, and x times 5 gives me 5x. So this factors into x plus 1, 2x plus 5. And now I just need to figure out, okay, what are the values of x that would make each of the factors equal to 0? So we could have x plus 1 is equal to 0, or 2x plus 5 is equal to 0. This one, we just subtract the 1, so x is negative 1, like that one. This one's not as friendly, but it's not too bad. We'll subtract the 5 and divide by 2. And I honestly would leave it like that. I would say x is negative 5 halves. Okay, you could say negative 2.5 if you wanted to. But not everything divides really nicely. So there you go. So hopefully that's not too bad. If you've done the practice with this the way that you should, then the factoring just gets to be much faster and easier to go through the factoring. And it's not. But if you haven't practiced with the factoring, then it's like this just becomes almost, it probably feels insurmountable. Okay, so what's an application of this? So we're going to actually go back retro into the last unit, all right? And we're going to open up this one. So we have the flying squirrel jumped from a tree 11 feet in the air at an initial velocity of 9 feet per second. The equation h equals negative 2t squared. What is that? Plus 9t plus 11 models his jump, where h is the height in feet and t is the time in seconds. And the third question on that was, when did the squirrel reach the ground? When we did this before, we really focused on just interpreting, like, when does the squirrel reach the ground? Well, that would be the x-intercept, because that's where the height would be 0. And that 0 should ring a bell for you, like 0 product property. Yeah. Okay. So how would you do this without Desmos? What would that look like? So when the squirrel reaches the ground, so just so we can see what we're dealing with, you've got some situation like that, okay? And you're looking for when the squirrel hits the ground. You might want to go back and refresh on this, but we did cover this. So you've got the squirrel going up, okay? So the squirrel is going up and then comes down, and the motion is quadratic, and the squirrel hits the ground right here. So what you're looking for is that point. Now, we have the h value, and we know that the height of the squirrel when the squirrel hits the ground is 0. So the height there is 0. So I'm going to go ahead and take my equation, okay, and plug in 0 for the height, because that is indeed what the height would be when the squirrel hits the ground. And now I've got something here that can be solved. And you could kick in the quadratic formula here. You could try to factor it. It is factorable. Now, what I don't like about that particular factorization is I don't like to factor when I have a negative out front. And what I would do in this case is I would actually take all of that stuff and I would move it over to the left-hand side. So I would take the t squared and add it to both sides. I would subtract the 9t and subtract the 11 and basically rewrite that so that I was dealing with a positive 2 and a negative 11 and a negative 9. Essentially, you flip all the signs, but the operation that's happening is you're adding and subtracting from both sides of the equation. You can factor, though, with the negative leading coefficient, and I did tinker with this before I decided to put it in the presentation. So we're going to go ahead and just like try to deal with that factoring with the negative, just so you can see what it does. Okay, so we got negative 2t squared and we have the 11, and math is consistent. So we're going to do negative 2 times 11 to get negative 22. And what I want are two factors of negative 22 that add up to positive 9. And so we've got 1 times 22 and 2 times 11. And thankfully, 2 times 11 does work. If it needs to be a positive 9, then it would be a negative 2 and a positive 11. And so I'm going to go ahead and put in the negative 2t and the 11t. And now we're going to GCF factor on this. And I always get like a little antsy because I'm not sure where to pull the negative out. When you have a positive leading coefficient, then you know you'll have a positive and a positive, right? When you have a negative leading coefficient, now one of them could be negative. And I actually tinkered around with this and did it more than one way, and it works both ways, which is really nice. But I'm going to go ahead and do a GCF factor right here and say that my greatest common factor is negative 2t. So I have the negative 2 in common and I have a t in common. So this is negative 2t, which means that that would have to be a t up there, which makes this an 11 and this a 1. And then we could double check 1 times 11 is 11. And so my factors here would be t plus 1 and negative 2t plus 11. And so t plus 1 could be equal to 0. And now that is like not the same as what I had before. I promise I did it out. Okay, give me a second here. Okay, we're good. I'm not totally sure what I did before, but like we're fine. So just had to double check that. Okay, subtracting the 1, so we get t is equal to negative 1, which is a solution, but that would be like that point way out there. That's like negative time, so we don't care about that one. And then the other one could be negative 2t plus 11 equals 0, and we would subtract 11 to get negative 2t equals negative 11. Now, this one, I actually would change it to a decimal because it's an application problem and it has to do with time. And so you could get the 5.5 seconds, and that's what we would have gotten off of the graph. which I did go and double check. And so that's how you would solve that by factoring. You could also bust out the quadratic formula for that. Now, just before we leave this, I do want to show you like how this actually works out. So I factored out over here a negative 2t because I could see that there was a negative in common, but you might have just said 2t instead. Okay, so you might have said 2t, and that would make that negative t, which would make this negative 11 and make this a negative 1. And you think, well, how can that work? But it actually does work out the same way. And so if you wanted to, you could tinker around with that and it would come out with the same answer. So it actually does not matter where you put that as long as you follow through with the whole area model there. All right, so what is up for you guys? So here's your practice set. For numbers 1 through 5, solve by factoring. So you're going to get some more practice with that factoring. Make sure you do have the 0 on one side. And I tried to mix it up. We have some that have a GCF. We have some where the GCF is all there is. So lots of stuff to keep you busy there. For number 6, I want you to solve that using the quadratic formula and then take the same equation and solve it by factoring. And then I want to know from your perspective, which strategy did you prefer, the quadratic formula or factoring, and why? Make sure you answer both pieces of that. So which did you prefer and why? I'm not looking for a specific answer. I want you to reflect on your own like practice there and what you prefer. Then on Desmos, you're going to take that same thing, and instead of a 0, you're going to put the y in, and I want to know what you notice about the x-intercepts for that. And then I want you to, this last one, number 10, explain the difference between just factoring x squared plus 2x plus 27 and solving, and if you're wondering what is underneath my head there, solving x squared plus 12x plus 27 equals 0. So what makes the direction factor different from the direction that says solve? And what makes just the x squared plus 12x plus 27 different from x squared plus 12x plus 27 equals 0? Very, very important that you notice that those are not the same problem and with the same directions. They're connected, okay? Like they're very closely related, but they are not actually the same problem. So make sure that you tackle that. As always, you guys know where to find me, and bring your homework to next class.